In this video, I will use an example to illustrate how to compute limits when we run into an indeterminate form of exponential type. The exponential indeterminate forms are 0 to the 0, infinity to the 0, and 1 to the infinity or 1 to the minus infinity. They are all indeterminate forms. Don't be tempted to say that the answer is 0, infinity, and 1. It isn't. The answer may be many different things, that's why they are indeterminate forms. I'm going to work with this example. The trick is going to be to take the exponential and use logarithms to transform it into a product or a quotient, because we have tools for indeterminate forms which are products or quotients. As usual, I invite you to pause the video and try to compute the limit first, or at least understand what the difficulty about it is, and then continue watching. I want to calculate the limit as x approaches 0 on the right of 1 minus x raised to the power of 1 over x. Before I do anything, let's find out what kind of indeterminate form, if any, I have. As x approaches 0, actually it doesn't matter on the right or on the left, 1 minus x approaches 1, and 1 over x approaches infinity, because we are on the right. So I have 1 to the infinity. This is an indeterminate power. Don't be tempted to say it is 1. The answer could be anything, and in fact is not going to be 1. It's going to be something else. Now, this is an exponential. And the trick is to try to transform this exponential into either a product or a quotient. Because we have tools. We know how to use L'Hopital's rule for products or quotients. And the way we transform a power into a product or quotient is by taking logarithms. So I'm going to do the following. I'm going to give a name to this function. And now I'm going to compute its logarithm. So the logarithm of this function, well, that's simply the logarithm of 1 minus x to the 1 over x. And now I can apply the properties of logarithms and take this 1 over x multiplying. Is 1 over x times ln of 1 minus x. And see, now this is a product or quotient, depending how you look at it, which is better. So what I'm going to do is first, I'm going to calculate the limit of the logarithm of f. That's not what I want. What I want is the limit of f. But first let's calculate the limit of the logarithm of f, because this is easier. And then once we have done that, let's go back to the problem that we actually care about. So once again, first I compute the limit of the logarithm of f of x. That's not my ultimate goal, that's just an intermediate step, and then I will compute the limit I care about. So I'll just copy the expression I have for this logarithm. And let's see what kind of indeterminate form this quotient is, if any. As x approaches 0, 1 minus x approaches 1, and logarithm of 1 is 0, and on the bottom I have 0. So perfect, this is the indeterminate form for which I can use L'Hopital. And notice that I should get an indeterminate form at this stage if and only if I start with an indeterminate form. Otherwise we're probably missing something. So I'm going to use L'Hopital's rule to try to compute this limit. If I use L'Hopital's rule, this limit will be equal, assuming this second limit also exists or is infinity or minus infinity, to the following limit. In the numerator, I need the derivative of ln 1 minus x. So that's 1 over 1 minus x times the derivative of 1 minus x, which is minus 1. And in the denominator, I need the derivative of x, that is 1. Alright, so this simplifies, and I think this limit is easy. I get minus 1 over 1 minus x, and as x approaches 0 on the right, or on the left for that matter, this limit is minus 1. But notice that I am not done. This is only the limit of the logarithm of f of x. So my second step is to compute what I actually care about, which is the limit as x approaches 0 on the right of f of x. How do I recover the function from the logarithm of the function? Well, f can be written as e to the logarithm of f. That's it. And now here we have computed in the first part that this is approaching minus 1. Therefore, e raised to that power is going to be approaching e to the minus 1, or equivalently 1 over e. In order to do this, I'm using the fact that the exponential function is continuous. So that's all we needed. The original limit, the one we were looking for, is 1 divided by e. If you would like some further practice with indeterminate forms of exponential type, you can try computing these 4 limits. You can use the same idea that I used in this video for all 4 of them.